Right, so hello everybody. Welcome to our whole training series. We organize a series every semester to let new students, new users of our system to get familiar with our system and be productive in using it. As usual, we start with the getting started with the whole introduction tutorial delivered by Dr. Davei Mu. This tutorial typically just introduces to the basics of the system and the main ways to interact with the system. And later on, we will have additional tutorials which will talk about how to actually use the system for machine learning tasks. So with that, I would like to welcome Dr. Mu. He is a systems engineer working in the Innovative Systems Laboratory, where he is managing the whole system. So you probably have seen, you probably have interacted with him in the past through the Slack channel or through our support mailing address. He is the one who deploys the software, configures all the services and tools, and also works with the users to help them to get started with the system. So as you start working on the system and you run into technical issues, Davei would be your first point of contact. And so with that, Davei, welcome, and please take it from here.
Great. Oh, hi, everyone. Good afternoon. Welcome to our training series. Today, my topic will be getting started with the HAL. So let's get started. So first, HAL system overview. The HAL system is a NSF-funded IBM cluster for deep learning applications. This machine contains 16 compute nodes with 2,560 CPU cores, as well as 64 media GPUs. This system also has 336 terabytes of all flash storage, which it's greatly improved the I/O efficiency of this system. And the system name is based on a very iconic sci-fi movie, the 2001, A Space Odyssey. So inside this movie, the main computer called HAL 9000 is a very early concept of an artificial intelligence system that's raised against humans that end up almost killing everyone in that spaceship. So in the 2019, we are brave enough to revive this machine back. And let's continue. Let's talk about the hardware. So for this cluster, we have one login node using the IBM 9006-12P. This login node has two 16-core IBM Power 9 CPU with 256 gigabytes of memory. I need to stress here that since this machine is shared by all our users, and this node do not have any GPU resources, so this node is not designed for run any computational tasks. So just I want every user to remember this, because if you running some very heavy computational job, you're gonna occupy all the computational resources. The cluster will be not accessible by other users. So that will be a very selfish move. Second is talking about the power source of this cluster, 16 IBM AC922 server. Each server will have a 220-core IBM Power 9 CPU, 256 gigabytes of DDR4 memory, 4 Nvidia V100 GPUs, I mean, the V100 GPU is no longer the most advanced GPU at this time. The latest one will be A100, but the V100 is still very capable. When we, especially at this time, no one can really purchase a GPU from anywhere. Am I right? And each node will have 2 ports EDR 100 gigabit InfiniBand adapter to make sure the communication between nodes. And then, as I mentioned before, I want to stress it again, that is we have the 3 DDN GS400 NVE flash array. This array provides us 336 terabyte of usable memory. We're using the Spectrum scale file system known as GPFS to share this storage among all our login nodes and the compute node. Now let's talk about our compute node structure. As we can see here, that each node will have 2 sockets, each for 1 IBM Power 9 CPU. This 2 CPU is connected by XBus, high-speed XBus, and then each CPU will connect it with the CPU memory with a bandwidth of 170 gigabytes per second. And then we can find there's 4 Nvidia GPUs. Each socket will directly access 2 GPU. Our system is very alike the also previous world #1 system from Oak Ridge National Lab called Summit. The Summit will have 6 GPU per node, which make their CPU and GPU interconnection speed down to 50 gigabyte per second. As we can see here, since we have fewer GPU, we have a higher bandwidth for the communication between CPU and GPU, GPU and GPU, which we can achieve 75 gigabyte per second, which means we have, if we configure this right, we have a better parallel efficiency for the distributed training workload. And then let's talk about the IBM Power 9 CPU. This is a very powerful CPU, and I have highlighted a few key features that I want our users to get a better understanding. First is this one have a stronger thread performance, the SMT4, which means each physical core has 4 hyperthreads. So that's why the 220 cores with SMT4 will map to OS as 160 CPU cores per node. This Power 9 CPU also supports NVLink 2.0 and the PCIe Gen 4 for high bandwidth between CPU and the GPU. Now let's talk about the Nvidia V100 GPU. This GPU can peak a 7.8 teraflops for double precision, 15 teraflops for single precision. The memory bandwidth of the GPU memory is 900 gigabytes. Also, this one has a large 128 kilobyte L1 cache and the 96 kilobyte share memory per stream multiprocessor. And now let's talk about the software. So the software we're using the operation system is Red Hat Enterprise, Linux 8.4. The compiler we have is GNU 8.4.1, CUDA 11.4, and Nvidia HPC SDK 21.5. We also have installed some other machine learning related or parallel computing related softwares, such as the OpenCE 1.3.1, the OpenCE and the Power AI we're going to talk about are machine learning related to two sets that these two sets have different versions of TensorFlow, PyTorch, and the Rapids, and so on, which designed for helping our users to run their machine learning code. We also have OpenMPI 4.1.1, which in charge of the communication between the message communication and the message passing between different nodes. For the auto building software, we have a CMake. And as for the container solution, we have Singularity 3.8.0. So our users are allowed to build their own Python environment, as well build their own Singularity container for their work. And now let's talk about our programming environment. So since we have so many software installed on the system, we need an environment management software to help our users to upload and remove the correct software in and from their environment. The software we choose is LMod. The LMod is a Lua-based module system for dynamically altering the environment. The basic commands are listed as below. The module avail will show a table of the current available modules. The module list will show a list of currently loaded modules. As the module purge will unload all loaded modules, and the module unload will load a single module from this current environment. And of course, the module load will load a module into the current environment. Since we are sharing this cluster with many users, so we need to have a software for workload control. We use Slurm, the workload manager, to run the system control for this cluster. The reason, there are a few reasons. First, the Slurm is free and very powerful. Another very important reason is that the Slurm is widely used by the Exceed organization, which means if you know how to use Slurm, you will have no trouble using many other similar clusters among US college and research institutions. So we will, this is basically a structure of how this Slurm works. So on our login node, there will be a control daemon that on this node, the user can submit requests for computational resources or check out the current status of this cluster, or checking where their job is waiting in the line. And for each compute node, there is a Slurm daemon that is working as client mode. That this will accept the request from the user through the Slurm control node, and then start get the computational work executed on compute node. So we have some simple policy for our user so that each excuse me, so that each user will have a fair share of our computational resources. So each user could have a maximum 5 running jobs at the same time. And for all the user, per user, all the jobs are allotted on 5 different nodes. As for GPUs, a single user can have 16 activate GPUs at the same time, and the maximum wall time for each job is 24 hours. These are the basic rules we set up for our user so that everyone could have their fair share. But as a user, if you have some specific requirements or you have a deadline to catch, you can always contact our administration team that we can help you to achieve your goal by giving you a temporal exception. So if you have any requirement other that please just contact us. We'll be more than happy to help out. And now let's talk about how to use Slurm. The original Slurm command could be complex. You can see that the following whole three rows is basically asking the system that I want 1 node and 4 GPUs and all 160 CPU cores for 24 hours. This is too long to remember, right? So to help our users to easier use to use our system easily, we developed a software called the Slurm wrapper suite. The rule of thumb of the Slurm wrapper suite is that we want to minimize the required input option, and we want to consistent with the original Slurm run script format, and then we submit the job to suitable partition based on the number of GPU. Let's get started with SWRun. The original Slurm command SWRun is to request an interactive session, but you need to input a lot of options that will be quite hard to remember. And based on our previous experience, some users will have a very bad choice for the CPU and the GPU and the memory configuration, which could somehow reduce the performance of their own work. So we developed this SWRun. Will help our users to request a interactive section. This SWRun only has 4 options, and only 1 option are required, which is the partition. The other 3 are CPU per GPU, the wall time, and the singularity container. As we mentioned, in our Slurm wrapper suite, we submit our job no longer to the GPU queue or the CPU queue. We submit the job based on the number of GPU that you want to run your job with. So we have the virtual partition name GPU X1, GPU X2, and GPU X3. The CPU per GPU, we have a default value for 16 because this 16 and the maximum is 40. since we have a 4 GPU per node, the 40 CPU per GPU will took all the 160 CPU for the whole node. And the wall time, the smallest unit we accept is 1 hour, and the default is 4 hours, and the maximum, as we mentioned, is 24 hours. So basically, the default setting, if you selected the GPU X1, we will give you 16 CPU cores, 19.2 gigabyte of the CPU memory, 1 V100 GPU for 4 hours. So more thing we need to talk about is first the debug queue. So the reason we set up our default wall time as 4 hours is that we have a debug queue. So in this queue, user's job will have higher priority, but we designed this for our users to debug or develop their own their code, so that we only allow 4 hours and less job to be submitted in this queue. You do not need to specify the debug queue yourself. As long as you submit your job less than 4 hours, your job will be automatically sent to the debug queue. And also, the debug queue only works for single node. If you want to submit the job with multi-node, even use input less than 4 hours wall time, you will still go to the normal queue. For singularity, we have a option -S, which you can specify the name of your container image. There is an environment variable called HAL container registry. By default, you will point to our shared singularity image pool. But if you want to create some singularity image by yourself, you are welcome to do so, and you just simply export the container registry variable to your own directory. And let's see how we use Slurm wrapper suite here. So as I mentioned, there's a 3-hole row of Slurm command for asking one node with 4 GPU, 160 CPU for 24 hours. And if you use our Slurm wrapper suite, you only have these options: SWRun -P, GPU X4, -C40, -T24, which means I want 4 GPU, and for each GPU, I want 40 CPU cores for 24 hours. So we simplify the input so that you don't need to remember all the details of configuration, because our Slurm wrapper suite will, based on the number of GPU you choose, we're going to calculate for you. And let's talk about SWbatch. SWbatch is a wrapper for original Slurm command SWbatch. SWbatch will allow you to submit your job within a SWbatch script, so that for the interactive jobs, you need, after you submit your job, you need to wait in front of your computer, wait for the cluster have enough resources, and then you will be bring to the compute node to start your job. But if you submit the job with SWbatch with a batch script, basically is that you submit your job into a specific queue, and then you do not need to worry anything. You can do other job. The job will be queued in the system. One it's your turn and the system have enough resources, your job will be executed automatically. They also have the standard output and the arrow output for you to check if your job running correctly or not. Again, the SWbatch try to make the batch script easier. So we have 7 options. Still, only one option, the partition name, is required. The other options are CPU per GPU, wall time, the job name, the output file name, error file name, and the singularity container. Let's see this example. Basically, this for the upper parts, there is a example.slurm batch script. Basically, we are requesting one node, one GPU, 16 cores. Each node will one socket per node, and each socket will have 4 cores, and each core will have 4 threads. So that's how many inputs we need to correctly request a single GPU job. And then at the end, the Python 3 amnist the trim PyTorch is the command we want to execute for our job. With our Slurm wrapper suite, our user can simply reduce the 12 line of batch script into only 3. So basically just SWbatch partition GPU x1, and then the command of your how to run your job. So this is way easier rather compare with the original Slurm command. Another cool features of our Slurm wrapper suite is that we have a command called SWQ, which is a wrapper of original Slurm command SQ. The SQ, if you type in SQ, it will show you all the running jobs, all the killing jobs, as well as those jobs are just finished. And you can have you can basically see which node is running which job, and where your job is waiting at, and what if your job is close to be executed, which node this job being assigned to. So it's very informative command. But our SWQ give you another angle to see the current status of our cluster. As we can see here, that if you type in SWQ, you will have a colored table within your terminal. The left-hand side, you seeing the usage of the CPU, meanwhile, on the right-hand side, you see the usage of GPU. So basically, this table telling me we have 4 idling nodes that are available for our users to submit job. And also, let's say there is a HAL 14, our 14th compute node. There is a user is using 64 CPUs, but no GPUs. So which means this node still have 96 CPU cores in idle, and all the GPU are in idle. So let's see if all those 4 nodes from HAL 06 to HAL 09 is busy. If you have a job, if you can change a little bit, fit your job within 96 CPU core with 4 GPU, your job will be executed right away rather than your job requires all 160 CPU. So your job will be sitting in the queue waiting for the next available nodes to execute the job. So there are several frequently asked questions. First one is, why partition X1 doesn't work with SWbatch. So the GPU X1, GPU X2 works only with Slurm wrapper suite because they are virtual partitions. Only our Slurm wrapper suite will recognize these partition names. If you are using original SWbatch, the only validated partitions are GPU and CPU. We recommend our user to use our Slurm wrapper suite, but if you are a experienced user, you know Slurm very well, and you know what you are doing, you are allowed to use original Slurm command. So just remember, if you're using SWbatch, this original Slurm command, the only partition available is GPU and CPU. And second, why I get index error, string index out of range error when using the SWbatch. First, excuse me, the Slurm wrapper suite requires some packages like PyYAML. So our users tend to, some of the users tend to create their own Python environment and use it as the default environment, even when they log in the system. So in that case, their default Python system might not have all the required packages that our Slurm wrapper suite requires. So if this happens, we would like you to deactivate the current Python environment and using our default Python environment to use our Slurm wrapper suite. And the third one, why my job always end up killing? The reason you can find with SQ, as I mentioned, each job will have some detailed information, and one of the information is what's the status of this job. If your job is running, it will say running. If it says it's killing, it will give you a reason why it is killing. Some might say we do not have enough resources, or some says your job being assigned to a node, but this node is currently have some issues. We need to fix that issues to get this job done, executed. Anyway, you can find out some detailed reason of using this command. And also, you can also check your recent usage to verify your fair share. The fair share factor is if you heavily used our system in the recent, in a short amount of time, let's say 2 weeks, then your fair share factor will be reduced to a very, very small value. So when your job start to, when you submit your jobs in a priority index will be multiplied with this fair share factor, which is the final score of your job's priority. So you use a heavily used our system in a very short amount of time, your fair share factor will be reduced. So in that case, other users to have their fair share. But basically, our fair share factor will be updated bi-weekly. So just keep that in mind. And now let's talk about some cool features about our cluster. We have implemented the Open OnDemand on HAL system as a web-based portal. This Open OnDemand service, including the Files app, which user can manage their own data, the Jobs app, which user can submit and monitor the job. And then also we have the shell access app that allow our users to using our cluster just like a traditional way using a terminal with SSH. But the difference is that this shell session will be held on our cluster rather than your own laptop. So in that way, you do not need a system or Linux that or Windows will have. You need to install a terminal app or something. You only need a web server, a web browser to get full access of our computational resources. And then last but most importantly is our interactive job. The interactive apps, including the Jupyter Notebooks, Tensorboard, VS Code, and the H2O AI, which we will introduce in the following slides. First is the Open OnDemand main page. You type in our HAL-Open OnDemand.ncsa.illinois.edu. You will be transferred to this authentication web page. You need to submit your username, your password, and then you need to ask the website to send you a push to your Duo app that you installed on your cell phone. And then after you verify this push, you will be brought to the actual main page of the HAL OnDemand. As we can see here, the main menus are listed on the top bar, which is files, jobs, clusters, and interactive apps. So let's explain this one by one. First is the file app. After you click that, you'll be brought to a web page that is basically just like a normal file management window within your OS, like Linux. You have full access to your own home directory. You can create a new file, create a new directory, upload files from your local computer, or download the file to your local computer. You can copy and move, and delete the file or path. The thing is, we have a limitation. Each user can only access the path, the folder that they already have permission to access. And then the active jobs. As we can see here from the left-hand side, we have this. There is one user is submitting a job on this cluster. You can see on the left-hand side that there is a triangle-shaped button. If you click that, it will expand and show you more information. But from here, from this page, you can also see this user is using a Jupyter Lab, and the user's name, and how many times this job has run, and using which queue, and what status of this job. From the right-hand side, there's a full list of our active jobs. You can see some of the jobs are just completed in the green status. The dark blue shows the job are currently running, and the lighter blue is a teal, I believe, is showing that the job is queuing. If you click that button on the left-hand side, it will show you what's the reason this job is queuing. And then the job composer. The job composer give our users a convenient way to create a series of scripts to, especially for the Slurm batch scripts to run their job. So we have created a few templates for our users to use. So you can just click the new jobs button and create a new job from template, and use our templates to start to submit your job and to get better understanding how this system works. And if you want to use try to submit jobs with your own software or data, you can simply make a copy of our template and change the command and configuration accordingly. Then let's talk about the terminal. In the cluster, under the cluster menu from the Open OnDemand, we can have a shell access to the cluster. When you click the shell access, it will bring you to a new web browser tab. You need to input your password and then accept the push. Then, just like the right-hand side, you will be bring to our login node, the HAL login tool, from where you can just use your use our computational resources in the traditional way, just like you use other system with your local terminal. This one doesn't require you have a terminal within your local desktop or laptop. All the session is saved on our cluster. So it's safe and also very easy to use. And you can simply access our system with your cell phone or tablet. You don't even need to have a like a formal computer or laptop. And then let's talk about the highlights of our system, the interactive apps. First is the Jupyter Notebook. Under the interactive apps, if you click and choose one app, you will see a form that listed as the left-hand side screenshot. From here, since we are using the original Slurm command, the partition is CPU and GPU. If you have GPU-related job, choose the GPU partition. If you only need CPU, just keep with the CPU partition. And then choose number of work hours. And also there's a name of reservation, if any. This is if you have a, like I mentioned, have a deadline to catch or have some specific need for training purposes or other reason, you can ask for a reservation. The reservation means at a certain amount of time, your job will be executed right away rather than waiting in queue like other users. If you have any reservation, you can input here. And then is the number of CPU and the number of GPU. You can adjust the computational resources you want. I also need to mention, our system, the CPU memory amount is bounded with the number of CPU cores, which means if you request one CPU core, you'll be automatically assigned with 1.2 gigabyte of CPU memory. In that case, if you want more CPU memory, simply just request more CPU core. And then after you decide your configuration, simply click the launch button, and then you will be brought into another tab called My Interactive Sessions. From in here, you need to wait for very short amount of time, vary from a few seconds to maybe 1 minute, depending on the system, the workload level of the system. Your job will be resources will be granted, so the tab turn green, and you know the name of the host that this job is running, and also there is a timer shows how many minutes or hours that left for this job session. And then you can click the connect to Jupyter. You will be bring into the page of Jupyter Notebook. There's very important thing I need to explain here. The Python environment you use for default when you launch this Jupyter is only to launch this Jupyter Notebook, which means inside the default Python environment, it doesn't have any useful computational useful package installed. So you need to switch to other kernel. So when you click the new button right here, you will see a full list of available Python environment. Some in my this is I use as myself as a user, so you can see some of these Python environments are built by our administration team. It's shared among all users. Some of the Python environment is built by myself, so it's only visible by myself. Now everybody can see the same Python environment. So from here, simply pick the correct Python environment, and then you can start to run your Jupyter Notebook. Jupyter Lab. Jupyter Lab is very similar to Jupyter Notebook with more features. The options are pretty much the same. We have the partition option, number of hours, name of reservation, the number of CPU, number of GPU. After you click launch, your job will be also bring to the My Interactive Session tab. I also need to mention one thing. As you can see, right now I already start another job, but since I didn't kill my previous Jupyter Notebook, the previous Jupyter Notebook job is still hanging there, as we can see with the time remaining counter showing on the page, which means as long as I do not delete the job will be there, which is very convenient for our users. Like if you fortunately request a Jupyter session in the morning, but you need to go to a class at around noon, or you need to go for lunch, then you need to, or there is a network issue. You lost your connection with our cluster. In that case, you do not lose your active section. You can just reconnect to our HAL on demand cluster, and then by clicking the My Interactive Session button, which show on the right hand to the right to the interactive app menu, that this two square overlap button, you will find your currently active session, and you can reconnect to your previous job. It's very convenient. After you click the launch button, you will be brought into the Jupyter Lab main page. From here, we can also see if you want to start a new Jupyter notebook, you need to pick a default Python environment. And during when you pick the environment and start to running your job, halfway, you can also switch different kernels for running your jobs, just like the screenshot on the right-hand side. And then also another very interesting software is called H2O AI. This H2O AI is the version we have here is a community version, so it's free. And since it's a community version, it only supports CPUs. It doesn't support any GPU. So for this app, we only allow our users to choose the number of run hours and the name of the reservation. After we click launch and connect to H2O AI, we will find ourselves into a Jupyter notebook or Matlab-like interface. This software allows us to easily import the data, parse the data, and choose the correct machine learning algorithm to process our data and get the result. In the following weeks, I will have another presentation talk about basic machine learning algorithms and this H2O AI flow. If you're interested, please join us for the following session. And then Tensorboard. Tensorboard is a very popular visualization software for machine learning, deep learning user. For this, since we do not need any GPU support for the Tensorboard, we only allow our users to choose the Tensorboard log directory, and if they have any extra arguments, and the runtime, number in hours, and the name of reservation. And this is because we assigned a certain amount of the CPU resources to this. The user do not need to select number of CPU or GPU. After the launch button, will be bring to the My Interactive section, which will have the button of connect to the Tensorboard. After we connect, will be moved to a new tab that shows the Tensorboard interface and for the log directory you specify. Last but not least is the, this one I used the wrong picture. It's a code server. So code server is highly demanded by our users, as also as the users can specify the number of run hours and the name of reservation. If after click the launch, it will bring you to the My Interactive session with the connect to VS Code button. So inside this app, you will have a full capable VS Code editor, which means they have nearly all the functionalities as your standalone VS Code or you install in your laptop or desktop. Remember, when you launch this app will create a local folder within your own directory. So you are allowed to install the extensions for different functionality because it will be installed under your own directory. You won't affect other users' usage. So in that case, you can install all the extension as you want, and use the fancy editor, and all the session will be held on our our cluster, not on your own directory, not on your own laptop or desktop. So as I mentioned, all you need to have is a web browser to use our computational resources. For the web browser, there's one thing I need to mention, that for the Mac users, the Apple Safari web browser tend to have some issues, compatibility issues with this Open OnDemand. So we will highly recommend our users to use the Google Chrome or Firefox to use this HAL OnDemand portal. All right, that pretty much is all I want to talk about our cluster. The following time is our hands-on demo time. First, I will use maybe 10 or 20 minutes to go through all the functionality of our cluster, and the rest of time, the new users can use the reservation we have here, the UIUC_32, to just browse our cluster and run some commands that you want. And let us know if there are any questions. We will be more than happy to answer them. I think Professor just mentioned that if you are a new user, you need to log into our system with the traditional way, with terminal through SSH. Because the very first time you log onto our system, there will be a script that we will create your own folder for you. If you do not log in with terminal first, you cannot use our HAL OnDemand system because they will report that you do not have a home directory. All right, now let me close my PowerPoint and start a let me share another screen. Share. Okay, a new terminal. Let's log in. Let me enlarge. Okay, so let me see. Before I continue, is there any questions? Hello? Anybody hear me? Okay. So if no one responds, I will continue. So first is we log on to our cluster with terminal through SSH. Basically, you want to use the command SSH with your username at hal-login2.ncsa.illinois.edu. We do have a spared login node for this system. The default is HAL login. we are rebuilding that system right now, so it will be available in no time. But currently, the only working login node is HAL login tube. All right, so after I hit enter, I need to input my password and then request a push to my cell phone. If I click yes, then I am bring into the login node. As I mentioned, the login node is shared among all the users that to log in as a like a login point. We do not want any users to run any computational job on this node. So let's get started. First, I want to show everyone is that the SWQ. As we can see here, the SWQ gives us a table for all the current cluster usage. Now we can see that besides the HAL 14, all the nodes from HAL 09 to HAL 16 are idling because I create a reservation for all the user attending this presentation. You can use the reservation name to access these idling computational resources. All right, let me start with another thing. The command very important is SQ. So you can see we have a list of currently running and the queuing job. This job means from here we can see the job being submitted to different partitions and what's the job's name and the user that submit this job. This is the status of current job. R means is running. The PD means pending. So here is the runtime of each job. We can know that, okay, this job is running for 22 hours, almost 23 hours. It will be end in no time. So the HAL 14 should be available in no time. And then the node count. As we can see here, there's two jobs that queuing for a long time. We can see they request a node and 10 nodes. As we mentioned, the maximum node per user is 4 nodes. In that case, if the user want to get this job run, they need to contact us so we can make a temporal exception. And we can see there's also within the brackets there is a reason why the job is pending. These 5 is a priority, which means this job will be is under queuing and not being executed because the priority of this job are low. We can see this job. This job says the resources, which means there is no resources can hold this job. Once there is resources, this job will be run first because this job must have higher priority than this one. And then also let's check a command called sinfo. This sinfo will allow you to see the current status of each node. We can see here, there's 7 nodes been reserved from HAL 9 to HAL 16. There's 5 nodes in the state of mixture, which means they are not fully occupied, but there are some jobs running on that node. This allocated, which means these node has been fully occupied by the computational workload. There's no other job can be thrown into these throw into this node. All right. And let's talk about the Slurm wrapper suite, right? So like I said, if we want to run a job, SWRun, I want to request a single GPU job. GPU X P means for partition, GPU X1, and then that's it. Normally, that's it. But today, since we have a reservation, I need to input the name of the reservation to get the resources. As you can see, right away, because we have the reservation, the job gets executed right away. I get my reservation on HAL 15 node. As we can also, another merit of our Slurm wrapper suite is that we give you the correct command that for the original Slurm, which means if we so if these commands are the correct command for original Slurm command, so these are the equivalent of our SWRun command. Our user can check these and modify based on these correct settings to their specific request. And doing exit, we're getting out of here, and that's pretty much for the command line. And I think let me show you a SWbatch script over here. There's a demo SWbatch. As we can see here is that I have a job name and I have a output file name, and I specify the partition I want to run, and there is SWbatch tell the system I want to run for 24 hours. So for today, let's see, I need to rename the job name. I want to see this is a this is a read only at this moment. Maybe okay. So maybe we can, if this is a read only file. But as I mentioned, you can change it with a text editor or with our HAL on demand. We can use our SWbatch to submit this job. Or maybe I can, maybe I can copy these and create a new one, demo2.swb. And I'm gonna paste this. No highlight. Oh. No highlight. And this is controlled by myself, so I can make it demo2. This will be the demo2. The percentage J dot percentage N is actually is a index number of the job number and node name. So in that case, you will remember what this output for which job and run on which node. And then for today, because if I submit a job here, it will be thrown into the conventional queue for our to wait for this job for its turn. But today, since we have the reservation, we're gonna add in one line that tells reservation equals to UIUC underscore 32. Then we can SWbatch among this demo2, and we're going to submit the job. As also we can see here is that this is actually the tag I input for my SW script. And under here, we actually output a copy of equivalent SWbatch command, so that our user knows that our Slurm wrapper suite help you to calculate the untask per node, socket per node, cores per node, and the threads per node accordingly. So after this job is submitted, I think since we can check if there are any jobs submitted by myself. If not, probably it's already done. See here, it's already done because we have the reservation. The job gets executed right away. So you can see here, this job run on HAL 15, just like the host name I input for the job. All right, so now let's let me share my screen let me check out the output. Okay. Let me go through the our HAL OnDemand cluster. All right. So now it's after we type in the HAL OnDemand.ncsa.illinois.edu, we are bring to this logon page. We want to input the same username and password as we have for the system. Oh, what happened? Oh, maybe I opened this page and wait for too long. It's okay. Let me bring back. Let's from start. HAL OnDemand in CSA, and then mu my password. Okay, this time it's correct. I set up the push automatically, so it will bring me in. Let me make the font bigger. First is the home directory. As I mentioned here, we have these functionality: create a new file, new folder, upload file, download file, copy or move file, delete file. And also, this is if you click a ASCII file, I will pick one down below. This all folder. Okay, so this one. If I click this one, the HAL OnDemand has a built-in editor. So this one is not as powerful as our VS Code, but this one is also have all the basic functionality that you can use. All right. So let me close this, and let's work through the second one, the active job. So as you can see, currently this tab means your job, which means my job. My job just completed not very long ago, so the record is still showing here. So if I click this one, I will see some detailed information: job ID, job name, the user submit, go to which partition, what's the state, and the total number of nodes, and which node is taking this job, total CPU, what's the wall time I required, and how many times this job is used. As I mentioned, I got the only what's memory I used for this job. And then if I want to see all the jobs like this, so right now I saw all the job information that currently queuing or running on our cluster. Oh, there's a lot of queuing jobs. Yeah, so we can also see there's just completed jobs, queuing jobs, running jobs. A lot of users are, you can see a lot of users are using our currently Jupyter Notebook, Jupyter Lab, and I think some users are using our VS Code for okay, I can show that later. Basically, that's what they use. Let's see the job composer. Job composer always a little bit slow. Let's move to another functionality, the shell access. All right. The shell access. Wait for a second. Okay, the job composer are open. Let's go to here. All right, so basically you can see I submit a few jobs with my previous previous usage. I mean, we can always create a new job from template. The template we have here is a TensorFlow MNet. I want to select the clusters to submit. It's our HAL. Right now it's a Red Hat 8. I'm going to create this new job. After I create this new job, it will copy the template files into my own folder. Just give it a second. I think because too many users are using this HAL on demand, so this cluster is always busy. Give it a second, and let's go to OK. This is a little bit slow. Let me reconnect. Yeah. Okay, but basically, I mean, while we are waiting, this is some details about this template. We will copy the whole template to our own folder, which include 3 files. The manifest, which will have the record of the job name, job description, and some information like that. The submit Slurm batch script is the files that we want to use to submit a job with a certain configuration, and then is the actual code. The one, oh, something went wrong. Let me go back. So let me continue. This is the TensorFlow MNIST Python code, which will be executed. So I don't know, today I may be too busy. Let me try again. So specify a cluster. Try again, and this seldom happens, but yeah, let's move on to this one is still waiting. So let's move on to our next demo. Is the interactive section, which the most highly used. First, that's from Jupyter Lab, perhaps. May I ask how many users are using our HAL on demand at this time? We can. Yes, I mean, if possible, I'm showing the functionality here. If possible, could you sign out at this moment for this moment? This is a little bit slow. Okay, let me get back. Okay, so maybe I should do something. Okay, so I will need to reboot the HAL on-demand server. Give me a minute. So the users can ask us questions now if they have any parts that it's not clear.
I have a question. Can I ask it?
Yeah. Yes.
For your Jupyter Lab instance, is it possible to select or like launch from Docker containers, like in Docker Hub, let's say, so that Jupyter Lab could spin up an environment that somebody like in a class or a course could, or for research reasons, like a container that contains all the machine learning dependencies they want to use. Is that possible that you could actually select a Docker container to use with Jupyter Lab?
First, I think it's possible, but we do not have a previous use case. The reason is you're talking about Docker. We do not support Docker directly due to some security concerns, but we do have Singularity, as I mentioned. You can port your Docker image into a Singularity image. But again, this image need to be executed and have the IPY kernel installed so that it could be picked up by the Jupyter Notebook. Otherwise, you cannot switch to that kernel. So,
okay.
Which will...
I was just suggesting, because, we have in Prairie Learn, they spin up, Docker containers on AWS and then provide a notebook interface. And it seems like you've actually done this now, but there's no GPUs there. So now with the HAL on Demand, you have a Jupyter Lab, which means you can host notebooks. And if you just went one step further and allowed the software environment to be defined through either a Singularity or Docker container, that would be the ultimate. So anyway, I just wanted to, it sounds like that you cannot do that within your HAL on Demand. You can't, your Jupyter Lab, you can't actually use a defined container, which would have a software environment that would be, so that I think it's a good use case anyway.
Okay, yeah, thank you for.
Sorry, it's a little outside of your tutorial, but I just thought I'd ask since you were waiting for that to boot, so.
Oh, yeah, I mean, yeah, we can definitely give it a try. Give it the time or our, if it's a highly requested by our user, we will definitely give it a try. Okay, now we have a, why this? I think partially because we are have so many users are sharing this machine right now. It's a little bit slow, but Okay. Oh, okay. Now finally it's here. So this is, let's start from the most interesting part, the code server, VS Code server. So for this, we only request number of hours and the working directory, but by default, it's your home directory, so it's okay. Just click the launch. They are more efficient. Can we get, there's a few questions. First is, do you have a recommendation workflow for moving between your local machine and HAL? For instance, Singularity is the best option for this. I will say for this one, okay, yes. So I'm submit the job. I've been bring to my my interactive session tab. We need to, this job is queued. We need to wait for a second for it to start it. So let's answer some questions. So workflow, because this machine is a IBM Power PC, which means they are not have the same architecture to your mostly x86 desktop or laptop. So moving workflow, that even you have the Singularity working on your own local computer, it won't working on our IBM cluster. I'm sorry, this doesn't work. But I will say you can always create a equivalent environment, Python environment in your own laptop or desktop, and then copy the code and data. And then, can we get an account if we are not currently working on a research project? The answer is yes. You can request a account, but you need to specify the purpose of your account, and you want to. We have a questionnaire. Will you apply for our account? So, yeah. I mean, basically, the answer is yes. You can request the account. Another questions. One, should we use HAL on-demand system versus submitting jobs through SSH? What is preferred in terms of using research in terms of easy of use? Yes, I will say, to be honest, I will say submitting jobs with HAL on-demand, in my opinion, is not easier than submit a job through SSH. Because the HAL on-demand, you still need to click the lots of buttons to get to your actual batch script, your code, right? So it doesn't help you very much. It just, I mean, if you only have a phone, you are on a party, you want to submit a job, I mean, definitely HAL on-demand, it's easier. You can hold a beer and submit your job with one finger. But if you are submit a series of production run jobs and you need to fine tune your code, you need to check how your job status, I will say using SSH and terminal is a better way. And also our HAL on-demand do have a terminal accessibility. So I will say I prefer, I prefer terminal with SSH, but HAL on-demand job composer is definitely another solution. And then, okay, supporting Docker container will be fantastic. I will definitely see using the feature. Yeah, okay, so Docker container, yeah, let us discuss about this. We need to find out how to make that work, because right now, inside the container by default, the user will be root, and since we are sharing our storage among all our users, we can now bear one user that has root access to other people's code and data, right? So we need to find a solution. But yeah, if a Docker is requested by many users, we definitely will find a solution for you. Yeah. And then, okay, so let's say, yeah, now the code server is running. As we can see, we have 4 hours. So right now, 3 hours and 47 minutes left. Right now, if I just close my computer and leave and work, my network broke. When I get back, let's say I left my work to for lunch and came back. Okay, so I can always click here and get my session back. Click the session. Yeah, we have this. I mean, I think this is quite popular. This VS Code is quite popular. There's no need for me to have a tutorial for that. I just want you to see that if you want to have some extensions like the one we're gonna use. I mean, Python is definitely something we need, and maybe I need a C++, so I can install the C++ plugin, and all of these will be extension will be installed in your own directory. So anyone will have their own set of settings. There will be no leak of your the data or your environment settings. So yeah, so let's see if we want to open PyTorch code. We can see it's already the key words is already been highlighted, and even more, if we go to here, this is the it's actually a Python Jupyter notebook. Let's see if we can find the Jupyter notebook. Jupyter notebook previewer, or yeah, right? We can have this previewer installed. Maybe this Jupyter converter installing. Give it a time. I mean, okay, now we can go back, open this again.
By the way, I think you need to restart the server because if you just install this plugin, it's not going to pick it up yet. If you restart the server, restart the notebook, reconnect to it again. Reopen. No, it didn't. Is there if you go to the menu somewhere on the left side, is there like a restart server or something? You know, so sometimes these plugins don't kick in immediately. So, but if you restart it, they will. Yeah, the way your microphone is off, so we don't hear you.
Okay, so this is a full version of VS Code. So when you open a Jupyter notebook, here is a button that show preview. It will open this. So this is the Jupyter preview plugin. It will show the what looks like, but I'm not sure it is runnable or anything. It's just a previewer. So we need to find. This is just a functionality shows that the extension is working. So yeah, let's try with something else. Tensorboard. So right now I have a default Tensorboard log ready, and click launch. And maybe at the same time I can start a. Just give it a second. Let me see if there's new. Okay, Jupyter Lab. So I will also start a section of this. We can see that later. And yeah. So let's see which one is ready. Go to my interactive session. All right, they're all queued. Just can give it a minute to make it work. So let me see the chat. Any other questions? How to use SSH to initialize? You don't need to do anything, just log in. While you first time log in, the system will create your own folder for you. So if you log in successfully, which means you already have your folder, which means the initialization process is completed successfully. Okay. Ooh. Oh, right. I forgot. I need to cancel this too, because because the other half of the machine is very, very busy. I think I forgot to input my reservation name. For the code server, we do not allow user to have a reservation because that node is only working for this code server. So right now, if I do UIUC, I need to do this and submit the job. This will be way faster, as well as the give me 1 second. We can submit the job. It shows permission denied. Okay, that's weird. So Yi Quan Wang, you can contact me after this presentation, and we can see what is going wrong. Oh. All right, you can see after with a reservation name, the job gets started right away. This one may be okay. So let's go to the Jupyter first. All right, as we can see, we have the Jupyter loaded. Let's just open a Jupyter notebook in the beginning to begin with. So right now I have a default Python environment called OpenCE 1.2.2. This one is perfectly fine because it has TensorFlow, has PyTorch. But I mean, I can always change the kernel. From the kernel side, we want to change the kernel. I can choose some from the list. Maybe, okay, let me think. I can switch to something else, sorry. Okay, I will choose something new, like this one. Oh, no, why this is not working? Okay, but I mean, like maybe just choose this one. You can see here, the environment has changed. So now I can run this cell. This one is also have all the basic information, all the basic frameworks installed, so it should be fine. So our user can use from here. Also, interrupt, restart. Just remember to pick the kernel, because normally the default you will have is this Python 3 IPY kernel. This one only have the PY kernel. It doesn't have any other thing installed. Just please keep that in mind. And then, okay, the Tensorboard is not ready. I think I didn't input the reservation name. Let's input that here. The UIUC under SWbatch 32. All right. Go back to here. Just wait for a second. Yes, this is starting. Give it a time, and I will open the terminal just, okay. This time the terminal opened right away. So let's input the password, send out the push, and now let's go in. So this is, if you log in for the first time from the terminal through SSH, you will see the exactly same welcome screen. So you are going to the right place. And the only difference is that this terminal is held on the cluster. So you can do exactly the same thing we did with previous command line. And let's go here. Okay, the Tensorboard is ready. Let's connect to the Tensorboard. See, I mean, here we have our epoch accuracy and the epoch loss ready. And to see the graph that we are using. So, right, there is another HAL H2O AI. I will leave it to my next presentation. So that's pretty much all I have to show. And our users can use the reservation to try out their tab or just run some of our demos. And I will be wait here to answer any question. It will be really nice to be able to define a software environment from user end. Maybe building some homework.
Sorry, it's kind of a repeat from my previous suggestion. Just
okay, yes. For example, for the PHY 398 MLA course I teach, we define a Docker-based environment and upload this to Docker Hub for use by Parallel Learn Workspace on AWS. But no GPU there, yes. So I will say first is that we can do pretty much the same. we can create a singularity image that will include all your software stack within it. And there's also a singularity hub. We can upload there.
Okay.
But the thing is, I'm not sure, but I never recall that AWS will have a PowerPC based machine.
No, forget AWS. It's just that I was just explaining how it's done currently is that we basically put a container for the course that has the student's environment to work with the notebooks, has any libraries, custom libraries we add, and then we put it in Docker Hub. And then what PrairieLearn Workspaces does is it launches a job on AWS and it spins up our container. And all I was saying is since you have a Jupyter Lab instance, you could imagine something similar where, except for now we have GPUs on HAL, where you you basically spin up a container that's defined for, let's say, a course or something. And then the Jupyter notebooks are already launched into that environment, and they can use whatever. Yeah,
sure. I think that's a good idea.
Something to think about. We can follow
help. Up. Yeah, we can definitely help with that. And if the cloud service is a must, I think IBM has its own IBM Cloud, which I assume they will support Power CPU, by default. So that's another. I just do not know the price of that.
You're right. Well, no, I was thinking more. You have these GPUs on HAL, and you have a Jupyter Lab, and if you were able to, instead of, you have a menu of kernels, but if you were able to pull a Docker, from Singularity Hub, something that a user uploaded to Singularity Hub. That has, and literally like that, if you look at that repo, it just shows the list of requirements. It's just a set of packages. And we use GitHub CI to build it. If we had, if we could put that on some hub such that your HAL system could spin it up as part of its Jupyter Lab, then you have everything. Then we have access to your GPUs. I don't know about the PowerPC thing with that. I'm not familiar with the platform so much, but if all the machine learning stuff works with the GPUs and in a Jupyter notebook, and it has the environment that we set in our Singularity container, then you have a very powerful framework for people to use, I think.
Sure. I mean, that's definitely, it's a good idea. Maybe we can schedule a meeting later and discuss the possibility how to create this environment.
Okay, that's all I had.
Hello.
Hello. Hi.
I'm Yi-Chen. I still have a problem to SH login. I'm not sure if it's the issue of the 2FA, because when I use the SH, because I use the one the professor sent to the textbooks, but I can type the password, but after I type the password, it show again the password, and this is said if I haven't set up the DUO, which is the 2FA. Duo, but I didn't get the push from the Duo.
Did you install that properly?
Sorry?
I mean, could you log into somewhere else with the Duo? I mean,
yes. I log in the website and Duo can push everything works okay.
Okay. For that case, I mean, you can contact me through Slack, and we can schedule a Zoom meeting. You share your screen, and we'll try to figure out what is going wrong. Is that all right?
I see.
I do have follow-up questions. Can we generate our own SH public keys to connect our server? Maybe if through that kind of process, we can just jump to the type of the password and the two factors process. Just use the public keys.
Public keys, I think you can, but the 2FA, the two factors is something you cannot jump.
All right.
Security issue. So, and
that's a bit of a
for
shame,
the inner part, what?
So you're saying you can't set up passwordless login with SSH keys because of the 2FA? Is that?
Yes, we do not allow that.
Okay.
The security team won't be happy about it.
Okay, got it.
Yeah.
So so I just send you email or some. How do we schedule a Zoom meeting?
So you know how to join our Slack channel, right? Join our Slack channel. Text me. I will send you the meeting link after this presentation.
Okay.
Okay, new question. We might need to wait a moment. I'm facing the same problem. A moment later, it works. After they see yes, I think the thing is, if you are very rigidly granted user, I mean, your user information needs some time to update to the NCSA user database. It's not like sometimes it will cost several minutes or 10 minutes or something. So yeah, wait for a while. Yeah, it could solve this problem automatically. Let me check how many users are. Yeah, no problem. 2.
Okay, so I guess if there are no any other questions, then we are done with today's tutorial. As Davey was saying earlier, join our Slack channel so you can ask questions there. This session is recorded. It will be posted online shortly after the end, and enjoy using the system.
Yeah, and yes, and also I will keep this reservation for a little bit longer. I think I will remove this reservation at 8 o'clock for tonight. So we'll still have a couple of hours. If you want to give it a try, feel free to do so. After 8 o'clock, I will remove the reservation. All our normal jobs will be occupied these computational resources. So don't waste this good opportunity.
Okay, Davey, thank you very much for presenting this. This was very insightful, very useful, very practical first step in using the systems. That's great. All right, then bye-bye, everybody.